Welcome back. This section, section 1.4, is properties of real numbers. We're going to be spending a lot of time taking some notes and going through some basic definitions. We're going to begin with the distributive property. You guys are familiar with the distributive property. It is the property that allows us to multiply something by a quantity. So whether we're adding or subtracting, it doesn't matter. Inside the quantity, here we have A times the quantity B plus C, and the distributive property allows us to impose A on everything in parentheses. So we end up with A times B plus A times C. And it doesn't matter which side of the parentheses that multiplier is on, we can still go ahead and do that. Okay? And it works for 2, 3, 4, it doesn't really matter how many things we're adding or subtracting in parentheses, we can go ahead and do that. So here we have A times X plus A times Y plus A times Z. And you can see over here on the right hand side, sure enough, we end up with AX plus AY plus AZ. And that does work in both directions. If we start here on the right and we have AX plus AY plus AZ, well, we have A as a common factor in each one of these three terms. We could essentially take the A back out and we'd be left with what we have here on the left-hand side. We can go in that direction. We can go from right to left and end up with A times X plus Y plus Z. You may remember that as essentially factoring, and we'll cover factoring more later, but it's the reverse of the distributive property. Moving on to the additive inverse. The additive inverse, any number added to its opposite is equal to 0. So if we have a particular number, one of my favorites I use quite a bit is 4. If we have the number 4, the additive inverse would be the opposite of 4. So 4 and negative 4 are additive inverse. They equal 0. Okay? So even if we had fractions, that's going to work for fractions as well. Okay? We have our fractions, negative 1/2. Well, we want this to become 0, so we add the additive inverse. 2. No, positive 1/2. I beg your pardon. So negative 1/2 plus 1/2 is 0. Okay? On to the multiplicative inverse. The multiplicative inverse, any number multiplied by its reciprocal is 1. So if I want to, I can work with 4 again. So work with 4, the multiplicative inverse of 4. Well, I want my result to be 1, so I have to multiply it by 1/4. So the multiplicative inverse is essentially the reciprocal. So if I had the reciprocal of 1/2 is 2. 1/2 times 2 over 1, that equals 1. More definitions, the identity for addition. So when you see identity for addition, you're going to ask yourself, what do you add to a number to get the same number back? What do I have to add to something to get a number back? So if I have, say, 1/3, 1/3 plus some number is going to equal 1/3. Why I put 0 there, I don't know. Okay, well, here we go. If I add 0, I will get 1/3 back. So the identity for addition is 0. Okay? Anytime I add 0 to a number, I get that same number back. The identity for multiplication, same kind of question. What do I multiply a number by to get the same number back? Well, I multiply anything, let's see, 4 times some number equals 4. Well, what's that number? that number is 1. So the identity for multiplication is 1. Doesn't really look like a 1, but it's 1. And the identity for addition is 0. 0 is our identity for addition. 1 is our identity for multiplication. More definitions. Terms. Terms, different than factors. Terms are numbers, variables, and values that are added and subtracted. Okay? So, terms are numbers 5, 7x, 8y, 2x cubed y squared, 7x squared y cubed. Okay, these are all terms. Even though like 7 times x and 8 times y made up of 2 factors, this as a whole, this is a term in and of itself. This whole grouping is a term, okay? Because I might try and add it. I might try and add 2x cubed plus y squared plus 7x squared y cubed. Well, I can't do that, okay? I'm not able to add those. Because looking below, okay, these are not like terms. Okay, 2x cubed y squared plus 7x squared y cubed, not like terms. Okay, like terms have exactly the same variables with the same exponents on those variables. So x cubed y squared and x squared y cubed, while I have x and y and I have cubed and squared, I don't have the same exponent on those variables. Okay, so what would be some examples of like terms? Some examples of like terms would be things like, well, 7x plus 8x. Okay, the 7x and the 8x are like terms. Okay, 3x squared y cubed and negative 7x squared y cubed. Now these are like terms because they have the same variables with the same exponents on those variables. And then we can add and subtract like terms. So we'd be able to add these two here and they would become, well, let's just subtract them. 3x squared y cubed minus 7x squared y cubed would be a negative 4x squared y cubed. Okay, the commutative property. The commutative property, to commute or to go back and forth or to make changes in location. Okay, commutative property changes our order. Okay, changes the order. So we keep the same variables here, but we change the order. So a plus b on the left is the same as b plus a. Or a times b is the same as b times a. It doesn't matter the order. And that only works for addition and multiplication. Okay, so I've changed the order. Versus the associative property. In the associative property, we have regrouping. We're changing who kind of we're hanging out with. Okay, the order stays the same. You can see here on both the left-hand side and the right-hand side, I have A, B, C, A, B, C. They stayed in the same order. But on the left-hand side, I grouped B and C in black. And on the right-hand side, I grouped A and B in red. So we had a different group, okay? B is hanging out with C, and now on the right-hand side, B is hanging out with A, okay? Well, that is regrouping, okay? That's the associative property. And again, this only works for addition and multiplication. It does not work for subtraction. So you can see below the example with multiplication. Order is the same. B is hanging out with C. Now B is hanging out with A. And then finally, we're going to move on to the multiplicative property of 0, which says any number multiplied by 0 will give us 0. Okay? And this isn't just one number, but any number of factors. As long as we're multiplying, if you put 0 in there, it's all going to collapse to 0. So if we had like 3x times 7x squared y cubed times 1/4 times 0, well, as soon as I multiply that by 0, since I have all multiplication in there, it's going to become 0. So that concludes section 1.4, and we will see you guys in class.